All right, so going over the chapter review for the chapter test in chapter 4, we are actually doing the test in the book. Number 3 says, please solve the following by factoring and or using the quadratic formula. Find all solutions. So in order for us to factor or use the quadratic formula, it has to be set equal to 0. This has the greatest common factor. And then it factors after that with a trinomial. And then we have 3 tiny equations, x equals 0, positive 5, and negative 4 for number 3. 4 is ready to solve, but it doesn't factor. Factors of 3 do not add up to be 3. So we're going to say negative b, so negative 3, 3, plus or minus the square root of b squared, minus 4 times a times c all over 2. 3 plus or minus 9 minus 12 is going to be negative 3 over 2. This will be 3 plus or minus. The 3 doesn't simplify, but the negative makes an I. And then we have 3 plus or minus I square root of 3 over 2. You need to know the quadratic formula. So for number 5, we are supposed to find all of these various things. X-intercepts, solving, we got 1 and plus or minus 2, so that makes 3 x-intercepts. Plug in 0, we get the y-intercept. In behaviors, negative x cubed, because negative x times x squared is negative x cubed. That means it looks like this. We can write the in behavior in math terms, and then we're going to plot everything. So I've got 1, 0, 2, 0, negative 2, 0, in behavior here. And then I've got a y-intercept of negative 4, 1, 2, 3, 4. So I know it's going to go down to 4, and I don't know exactly what's going to happen there, but there's an estimation of it. It could go around. As long as it goes to this point, it's fine. It has to have the right end behavior, which I sketched here. This is a good sketch for number 5. For number 6, a more simple equation. I only have 1, 0. It's going to be at 2. You can write as x equals 2. That's fine. When I plug in 0 for x, I get negative 8 for y. I have a multiplicity of 3. That means when I go to 2, it's going to be kind of flat there. I have end behavior like this, but it's going to be kind of like flat here and then go down. So, because it only has this 1, 0, it's going to cross at negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. There we go. And there's a sketch for number 6. If you didn't have number 7, you should follow along and add it to your notes right now. So to do an inequality, I'm going to do a sign chart. I'm going to factor this and find the zeros. So x plus 6 and then x minus 1. So my zeros would be at negative 6 and positive 1. So I'm going to do a sign chart that has negative 6 and positive 1 on it. And then I'm going to check what happens in between. So this is going to be a sign chart because I'm looking for the values here to be less than 0 or negative. So when I plug in numbers like negative 7, before I plug in negative 7, I've got these 3 intervals, negative infinity to negative 6. And I'm going to have this kind of bracket because it's not equal to negative 6 to 1 and 1 to infinity. And I'm checking each of these intervals here. So I'm going to plug in negative 7 right here. That'll be 49 minus 35 minus 6. And so that's going to be 49 minus 41 is a positive number. If I plug in 0, I have negative 6 is a negative number. And if I plug in 2, I'll have, so I plugged in negative 7, 0, and 2. 2 is going to be 4 plus 10 minus 6. 14 minus 6 is positive. So what I needed is I needed a number smaller than 0. I need these numbers, which means I need this interval, the solution set, is all the x's in -6 to 1 for number 7. Number 8 is a very similar problem. We also want to look at the sign chart here. So my zeros are going to be -1 and +3. So I'm going to put them here, -1 and +3. These are the values that make it 0, and I need them greater than 0. So I'm looking for all the x's that make this side positive. That's what I want. I want positive numbers greater than 0. So I'm going to test these intervals, -∞ to -1, -1 to 3. So that's everything to the left is here, everything in the middle is here, and then 3 to infinity is on the right. And I'm going to plug in numbers, and I'm going to do my sign chart this way, where I plug into the factors and multiply. So if I plug in a value less than -1, like -2, -2 plus 1 is -1. Squared is a positive number. -2 and -3, no, this is not squared. This is, well, they both are squared. Okay, so then -2 minus 3 squared is still a positive number. In fact, any number that I put in here, so even 0 plus 1 squared will be positive. Any number that you square is going to be positive, and squared numbers are positive. So what does that mean? I need positive numbers greater than 0. And all the numbers in this interval are positive. All the numbers in this interval are positive. All the numbers in this interval are positive. But I can't have it equal to 0. So it's going to be, I need to just say where x equals -1 or 3, it's not true. So I need to say x is not equal to -1 or 3. Every other value makes it positive. Just these two are not equal to 0. So these brackets tell me I can't include -1 or 3. So all real numbers except -1 and 3 for number 8. For number 11, this is pretty standard long division. I did put the zeros in to hold my places. I carried down my things, changed the signs everywhere. This work is here, so pause this video and go through the steps if you did not get x cubed plus x squared plus x plus 1 with 0 remainder. Number 13 says use long division, but this is a simple factor. I can use synthetic division, so I'm going to do that here. So -2, I use the opposite sign. This makes it so the negative in subtraction that you have in long division above in this problem, that gives you the negative you need. So it's always opposite math when you go here. I'm going to have 1 times -2, -3, that's 6, 8, -16. Note I put a 0 here to hold that place. So -16, that's +32, and I've got 28. So what's left, this is the remainder. It did not go in evenly, and I have to write my quotient like I did in number 11. So the quotient, I need to write that out. I can't just leave it like this without any variables. So I'm going to rewrite it as 1x to the third power minus 3x squared plus 8x minus 16 plus 28 over x plus 2. So the remainder gets written as a fraction, and this is 1 degree less than what I started with here. So x cubed minus 3x squared plus 8x minus 16 plus 28 over x plus 2. This is the division and what we have there. 14 says, here's a long polynomial. Is x equals 1, here's the value. They're saying, hey, k, is that a 0 or not? So if you use synthetic division, if it's already in this form, you keep it in that form. You place it here, put all the coefficients, try synthetic division. And because I got 0 at the end, I put a smiley face there. That means that, yes, 1 is a 0 because the remainder is 0 for 14. 15 is the same problem, except we're trying 1/2. So we're going to bring down 16, take half of it, that's 8. Then we get -12, half of that is -6. Subtract these two numbers, we get 2. 1/2 of 2 is 1. we get negative 2 plus 1 is negative 1. That's going to be negative 1/2. 3, which is 6/2, minus 1/2 is 5/2. So we didn't get 0 here, and this is the value. So if I was to take 1/2 and plug it into all of these various x's, the y value would be 5/2, the same as the remainder with synthetic division. 16, same kind of problem, except we're trying negative 2 here. At the end, we get negative 41. That's the remainder. That means if we plug in negative 2, we get out negative 41. Don't forget that's a point. It's not a 0 because we didn't get 0, but it is a point on our graph for 16. For 17, they tell us these three things. We have degree 2, so that's a quadratic. We have these two zeros, so we have both of them already. And as x goes to negative infinity, y goes down, which means that the other side goes down because it's degree 2. So we're going to have y equals negative x plus 2, x minus 1. The negative makes it go down. These are the two zeros written in factored form, so opposite math. I'm going to have negative x squared minus x plus 2x minus 2. Y equals negative x squared plus x minus 2. Y equals negative x squared minus x plus 2. For number 17, a degree 2 polynomial that goes down. And they did not even multiply it out in the book. Silly people. So they wrote it just like this, except they switched it to be, they wrote the answer y equals x plus 2, and they put the negative with this one and made it 1 minus x. This is fine with the negative in the front. This is fine. I'll multiply it out. Generally speaking, if they ask for a polynomial, you would multiply it out so it looked like a polynomial there. 18 says degree 3, zeros, and they give you all the zeros. Negative 3, 0, and 2. I don't know why I have parentheses there. Y-intercept of 0. So we're going to write it just the way they did. The really short version is we've got x for the 0, we've got x plus 3 for the negative 3, and x minus 2 for the positive 2. So that's the simple way. Now I'll multiply it out. So you need to read the directions. This is factored form. If it says polynomial form, you need to multiply it out. These just say constructed polynomial function. They didn't say what form they needed it in. That's why these forms suffice for these two problems. 19 says, here's a third degree polynomial. Please find all the solutions. So first I'm going to see 4 terms and I'm going to try to factor by grouping, but this doesn't work. The 5 messes us up. I know that from the beginning. So instead I'm going to start with by possible zeros. Plus or minus 1, 2, 3, and 6. And I don't have any fractions because I have 1 in the front. So I'm going to try 1, negative 2, negative 5, 6, 1, negative 1, negative 1, negative 6, negative 6, 0. So 1 works. That gives me x minus 1 as a factor times this x squared minus x minus 6. X minus 1, and then x minus 3, x plus 2. So x equals 1. Oops, I'll say negative 2 and 3. That's how I was writing them out, the negative there. So you do still need to know how to do possible zeros. They didn't ask you for that in this problem, but you would need to know how to find that. Same directions for 20, but 20 factors. So I'm going to do x to the third plus 2x squared plus 4x plus 8. I take out an x everywhere. These look similar. This is going to be something plus 2, and this is going to be plus 2. So I'm going to factor right again, x squared, and then x plus 2 plus 4x plus 2. I'm going to still have x. When I do factor by grouping and continue it, I'm going to take out the x plus 2. That leaves x squared plus 4. I don't need those brackets, but they just help me center my attention to this part that I'm still factoring. And I have zeros of x equals 0, negative 2, and plus or minus 2i. Because x squared plus 4 equals 0 is x squared equals negative 4. Square root, plus or minus x equals plus or minus 2i. So 1, 2, 3, 4, because I have to the 4th degree there for number 20. For number 24, this might have taken you a little bit of time, and that's okay to have a problem every now and again that you have to keep trying. So I did not do all the synthetic divisions. If this had been a problem that I would give you on assessment, I would give you a hint like, how about f of 2 equals 0, and that would give you started here. So we do find that we have x equals 2 and negative 3 once it factors like this. And at 2, it has a multiplicity of 3, so it's going to be kind of flat there. The end behavior, because it's x to the 4th, is going to be up on the ends. And I found the y-intercept of 0, negative 24, which is about here. So it's going to, at positive 2, it's going to kind of go flat. It's going to go down at least this far and then come up here at 3. So I don't know exactly what it does around this point. It may be the lowest point. It may not be, but this is a good sketch from here. I didn't ask for any other x values in my chart. So there's 24. 25 says, please find the polynomial with the stated properties. And again, they didn't say you had to multiply it out. They did multiply theirs out, but we could construct one without multiplying it out. We know that if it's degree 2, it has to have 2 solutions. So the other one's going to be 1 minus I square root of 2. We need its conjugate. Now we have both. We have a degree 2, so we're going to write our polynomial like so. We've got x minus this one, so it's going to subtract 1 and the I squared of 2. And then x minus the second one, so we're subtracting both of these. We'll change their signs. Now I would do this and not multiply it out, but I need to fix this. I need to have negative 6 as the y-intercept. So I do have to multiply this out to get this polynomial and include this particular condition. So I'm going to distribute the x over everything, the 1 over everything, and the I squared of 2 over everything. So I'll have x squared minus x, and then plus ix squared 2, negative 1 times everything, and negative 1, so negative I squared of 2. And this guy is going to be negative ix squared of 2. I'm doing this one, so that's going to be negative, and negative is positive I squared of 2, and then negative I squared, square root of 2 times square root of 2 is 2. So then when I add everything up, I've got x squared minus 2x. And then these cancel. I've got these cancel. This is going to be negative 1 times 2. That'll be plus 2. So this guy right here is plus 3. So I'm really close. I have a second degree polynomial. These are my 2 zeros. However, I don't have the negative 6. So to get that, I need to find the a value, the stretch value. It'll be negative 2. That'll give me negative 6 over here. So p of x equals, and then p of x we multiply negative 2x squared plus 4x minus 6. Now we've covered all of our bases and have a polynomial that has both the zeros and the negative 6 for the y-intercept. For 27, is x plus 3 a factor of this polynomial? I'm going to do, and they asked for synthetic division, so here it is. 3, 4, negative 18, and negative 3. Start with 3, that makes 9. 13 makes 39. And then this makes 36 would be, those were 2, so that's going to be 21. And that'll be 63. So no, definitely not. No, it is not. We didn't get 0 there. 29 says, hey, please find the vertical asymptotes for this equation. Note that it says find the equations of the vertical asymptote. So we're not just saying -1. We're going to say x equals -1. So in this case, the simple answer is x equals -1, and that's the asymptote for 29. 30 has the same directions, find the vertical asymptote, so we're looking at the denominator, but in order for it to be a vertical asymptote, it can't cancel at the top, so it can't be 0 on the bottom and the top. So we're going to need to factor both. That's going to be x squared times x plus 2, and then negative, oops, not a parentheses there, -1 times x plus 2, all over sum of cubes, x plus 2, x squared minus 2x plus 4. So one more time, x squared minus 1, x plus 2, x plus 2, and x squared minus 2x plus 4. This cancels. This is imaginary, so this one has no vertical asymptotes. What would you need to say? You need to say that at x equals -2 is a whole. You still need to say that. They didn't ask for that, but you should still follow through with that. You need it to graph. 31 and 32 are looking for horizontal. So now we're looking for the ratio of growth between top and bottom. So this is larger. This one's going to be horizontal, y equals 0. Oops, I didn't finish this one. This is x plus 2. This is larger on top by 1, so this is going to be slant. We need to divide it out. X plus 2 and x squared plus 0x plus 2x. We have, all right, so x times x is x squared, x times 2 is 2x. Change their signs. This cancels. I've got -2x plus 2. X goes into -2x, -2 times. So that'll be -2x minus 4. Change the signs, and I've got 6 left over. But 6 over x plus 2 is going to 0. So I can disregard this. And my equation is y equals x minus 2. That's the y equals mx plus b for the slant asymptote for 32. Then we've got 33, which says sketch the following rational functions. 33 we're supposed to sketch, so if we factor this out, this cancels, so at x equals 1, there's a hole. There's no vertical asymptotes because this canceled. There are no horizontal asymptotes because the degree is larger on the top. And now it's just the top. So this is going to look like the graph of x plus 1, but there's going to be a hole at 1. So at x plus 1, it would be here and up 1 over 1, but this is a hole, and everywhere else the slope is 1. So it looks like a line, but this made it have a hole in it, which makes it a rational function for 33. All right, so 34, you should have gotten so far as to factor it out. So I factored it completely. Nothing cancels, so I don't have any holes. I'm going to start with vertical asymptotes. They're going to be from the denominator. They're the same value, so that's going to be x equals 1. Horizontal is comparing the top and the bottom. That's probably easiest in this section. So I'm going to say x squared over x squared is the leading degree. They go at the same rate. So I'm going to make it a ratio. It's going to be y equals 2 over 1, or 2. So I can graph those things, +1 and +2. There we go. So defining features for my graph are on there. Now I need to find the y-intercept. So the y-intercept has 0 for x. That's going to be -4 over 1, so -4. 1, 2, 3, 4, that's a point. So the graph is going to be here. And then x-intercepts are going to be where the top equals 0. So this is already factored. 2, x minus 2, x plus 1 equals 0. That'll be at 2 and -1. So at positive 2 and negative 1, I have zeros. So clearly my two sections of graph divided by this vertical asymptote, I'm going to have one here, and it will come around and follow this line, and this one will go down following this line. And then I've got one that goes this way and this way. So 34, all the features that I needed and the graph. So 37 is a thinking question. They say, okay, you've got a vertical asymptote at x equals negative 2. Can you graph it without lifting your pen from the paper? And I mean, I guess you could fold the paper across this and just connect it over the fold if you were going to just be, you know, crazy about trying to get around the question. But no matter what happens, the line is going to follow the asymptote in one direction or the other, and you have to skip over this line. So no matter what you decide to draw, it's going to follow this line, but you can't graph at negative 2. Therefore, no. Without folding the paper somehow along this line and skipping over. Well, you still couldn't, because you'd have to have a line on both sides that goes on forever. So there's no way around it. No, you can't. All right, so if you have questions after watching this video, please let me know, and we can follow up with those before your test on Chapter 4. All right, thanks, guys.